On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, example number 9 of L'Hopital's rule, and we're going to look at the infinity to the 0 power form. We have this function f of x, and we want to find the limit of f of x as x approaches infinity. Well, let's go ahead and try that real quick. If we let x approach infinity, well, this is going to be infinity, that's that x right there, to the 1 over infinity power. Well, what is 1 over a really big number? 1 divided by a really big number, the bigger this number gets in the denominator, down here I have like, what, a million or something like that. Look at this number here. It's getting closer and closer to 0 as I make that bottom number bigger and bigger and bigger. Therefore, 1 over infinity, we're approaching 0 for that exponent. Check out our form, infinity to the 0 power. The way we tackle this one is very similar to example 8 and example 7. I encourage you to check those out before proceeding. And if you go back and look at those two examples again, we did rewrite this function. Y equals x to the 1 over x power, taking the natural log of both sides, which allows us to pull down this exponent like I've done here, and then converting this to an exponential, we have e to this power is equal to y. I've mentioned this in those previous two examples as well, but if y is equal to this and y is equal to this, then this thing right here is going to be equal to this thing right here. What we want to focus on is this exponent. Let's find the limit as x approaches infinity of this exponent. When we find that limit, our final answer to this problem will be e to whatever limit we get as we continue this problem forward. So therefore, I'm going to take this exponent. Let's find the limit as x gets big of 1 over x times the natural log of x. That exponent right there. This is going to be equal to the limit as x approaches infinity of the natural log of x over x. And now notice, if we let x get big for both the numerator and denominator, the natural log of a big number is going to be a really big number. The natural log of infinity is going to approach infinity, and as x gets big, well, this is going to get big down here as well. Notice we have an indeterminate form, infinity over infinity. Earlier examples, example 3, I believe, yeah, this one right here, and even example 4, we covered the infinity over infinity form. And basically all we have to do here is this. Let's take the derivative of the top and the bottom. This is L'Hopital's rule. And then let's try to apply this limit again. So taking the derivative of the top, the derivative of natural log of x is 1 over x. The derivative of x is 1. And since we are dividing by 1, we can ignore that now. Therefore, we have the limit as x gets big of just 1 over x. And this should sound familiar because as x gets big, 1 over a really big number, this limit here is going to be 0. However, this is not our answer. Just like in example 7 and 8, let's take this answer that we get here. Remember, that's the limit of this. And this was the exponent. And what we want to do now to find our final answer, the limit of f of x as x approaches infinity, is going to be e to this power. That's the limit of this. That is this power, so e to the 0, we get 1. And now let's verify this in Desmos. Here's that function, x to the 1 over x power, and we were finding the limit as x gets really big. So notice as I'm letting x get big, for example right here, x is around 12.6. The y value is getting close to 1, it appears. I'm zooming way out and I'm going to let x get even bigger. So right now x is getting close to 320. Look at that y value. That y value is getting closer and closer and closer to 1. And you can see it dropping. Now we're at 1.016. Now we're at 1.015. I hope you get the idea there. And there you have it, example 9. To my knowledge, examples 1 through 9 here that cover L'Hopital's rule, we've pretty much have addressed all the various indeterminate forms that you may get and the techniques you'll have to use in order to find those limits. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.